Hi, my name is Naoko Fukushi. I'm from Japan, and talk about a platform for storing road rate inspection data based on the local GEOID with the ITRF coordinate system. In Japan, 2012, the collapse of the Sasago tunnel occurs. The ceiling boards fell. In this accident, 9 people died and 2 injured. We got shocked so much. And this accident spread the recognition that the aging of civil engineering structure is a social issue in Japan. Then the periodic inspection once every 5 years of all bridges and tunnels has been mandated since 2014. These inspection records include so many items and are precise. So a large amount of inspection data has been accumulated continuously. Periodic inspection once every 5 years, all of bridges and tunnels has been mandated since 2014. So large amount of inspection data has been accumulated and continuously. At the point of a road pavement, dedicated road survey vehicle acquires the surface of continuous images, large data, laser data, and etc. of broad pavement. And records of condition would be created with over 100 items, including deterioration indices, repair histories, and positioning coordinates. In Japan, this is estimated that the 12,000 kilometers of road, which is 1% of the total 1.2 million kilometers, are investigated every year. So the more road pavement will be investigated and its road record will be created more wide area. Japanese government has been promoting research and developments of more accurate positioning technology. Semi-dynamic data will be a solution of cluster deformations. Electrical reference point in Japanese area have moved about 2 meters in average by cluster deformation and earthquake for 20 years. Their research target of pointing positioning accuracy is 1 cm levels. For the coordinate system, I will mention later Japanese government adopt GRS-80 ellipsoid and ITRF coordinate system. This coordinate system is able to represent cluster deformation. On the other hand, map projection is a Gas-Kruger projection. This is the image of a section the Earth's surface. The ellipsoid is a simplified shape of the Earth, and geoid is a virtual shape which is defined by sea mean level. And ground surface is a place we are walking on. The procedure to project a steep road onto the map is first you projected to the steep road to the ellipsoid, and second to project to the map. At this time, the scale factor depending on the longitude from the original is set, so that the gap occurred in the process of the projection onto the plane is within the 1/10,000. For the Therefore, there is a necessity to consider share of the Earth and the direction of gravity. International Terrestrial Reference System and frame is the Cartesian coordinate system and the Earth-centered Earth-fixed coordinate system, and used by surveying institutions in most countries. ITRF 2014 is latest version, and it is almost same with WGS 84. And GEOID is a presentation method of undulation shape of the Earth. The equipotential surface of the gravitational potential of the Earth based on mean sea level. Gravity depends on internal density of the Earth. At construction sites, vertical direction is equal to normal direction of the GEOID surface. We usually created a 3D model on a flat plane. If we want to place the model that someone created to next to your model, it will be to put on the flat plane. In the case of big and long structure like a train rails, long bridges or roads, their position where you put model gradually become far from the actual position because Earth is sphere. So with the large model and small model structure to visualize and store those inspection data. Large model is a 3D model for integrating multiple small models into one model. And the small model is a design, the design reference plane is a GEOID. Both models have GCP and reference vectors to place on the ITRF coordinate system. From here, this is a method to verify with actual data. Study area is the west area of Tokyo, and the method is calculated deviation of vertical direction of ellipsoid and geoid and topological surface. And we use data, the geoid and the elevation data. And procedure is one calculate values of elevation and geoid height from for each about 100 meters grid point. That is 3 seconds in latitude and 4.5 seconds in longitude. To converting the XYZ coordinate values of elevation, the geoid and ellipsoid into the ITRF coordinate system. 3. Creating 3D surface, creating 3D face using by AutoCAD Civil 2070. 4. Analyze the distribution of deviation between 3D surface, 3D face normal and reference normal. This is formula we used. This image data of geoid. This map presents height of geoid from ellipsoid, about 2 meters different from dark area to dark blue area to the green light green areas. This image elevation map. This is a 3D image of surface. Green one is a topography surface, and brown one is geoid surface, and gray one is ellipsoid surface. Then we analyze the effect of applying the normal direction of the geoid surface in the vertical direction of the small model. 3D face, the normal direction of the geoid model can be estimated by the angle of the 3D face normal direction of ellipsoid surface. So this image taking the 3D face normal direction of the geoid located in the most south and most west point as reference. Vertical deviation increase in proportion to distance as a whole. Deviation of about 0.09 degree, about 5.49 minutes at 10 kilometers from the reference point. The deviation of about 5.4 minutes will be different by 15 centimeters at the altitude of 100 meters. Here is the histogram of the deviation between the normal direction of the geoid and the normal direction of the ellipsoid surface, same place. This image, in the case of the bridge tower, if the deviation of the geoid to ellipsoid detail delta is これif the deviation of the geoid to delta is 27 seconds, then the point of 300 height of tower tops different become 4 centimeters. And when creating a digital mock-up from design data or conducting the construction simulation, if the same vertical axis is applied to the continuous small model groups, the difference will become larger for large-scale structures. The next is visualization. This is a mountainous area, and the colored line is road networks, and the red part is wrong condition, and the green part of the good condition of road. And conclusion, and we propose the ITRF coordinate system. In this coordinate system, 3D models consist from the large model and the small model. The vertical axis of small model will be the same as the normal direction of the geoid. In application to design data, we evaluated the effect considering the geoid by coordinate transformation. From the longitude and latitude rotation to the three-dimensional orthogonality coordinate system. Moreover, it verified the effectiveness of applying ITRF coordinate system to a maintenance and management project. And I will finish the presentation. Thank you for your attention.
Any questions from the floor?
Hello. As what you have mentioned, you just say that you integrated several models with big 3D models. So I'm very curious about how can we tackle with the problems of coordinate system transformation. I mean, how could we identify identical coordinate system? Thank you.
So do you mean the transformation from the raw coordinate system to this IP?
Yes.
Okay. So IP.
Yes. How to achieve the coordinate transformation? Yes.
And from what to IPDM?
Yes. From several small models to your system. Yes.
You mean the current one?
Current?
Yes.
In the 3D model, just only the calculated in the computers, simply how do I say we use the two coordinate system, and one is for to use the 3D model. That this is just simply the 3D orthogonal coordinate system, and geographic coordinate is a projected map that means belong the surface, and this so we use two coordinate. We propose the coordinate system is combine the two geographic coordinate system and CAD model coordinate system. I can.
Maybe the question was how to convert the spherical or longitude and latitude coordinate system to Descartes coordinate system.
How to?
I think the answer would be in Japan the Japanese territory is divided into 17 flat planes, and each plane has corresponding coordinate system with the longitude and latitude, and the Descartes coordinate system, Cartesian coordinate system.
Any other questions? I have a quick question. So about the deviation, you mentioned 15 cm, right? 15 centimeters.
Yeah.
deviation. So
Yeah.
what is the allowable deviation effect for the road or the 15 cm? What is allowable? Is it allowed? So
for-
for example, for the road, yeah, so what's the allowable?
The I'm sorry.
Yeah.
What was the question?
Yeah, the deviation is 15 cm. So for example, 15 centimeters. So just wonder what is allowable. So what is the allowance? Is it within the allowance? Or
So what is the code?
Exactly.
What the codes allow the deviations DB codes.
どれぐらいそのズレが違いがあっていいかっていう。
そうですね。
そうです。
Actually, I don't know, but in future I try this, and maybe the construct, I think depends on the construction side. I think, yeah.
Okay, thank you. Okay, so thank you for the presentation.